All right, let's just dive right into this. Welcome to this explainer, where we are going to completely demystify artificial intelligence. Now, if you just glance at the news today, it's super easy to assume this technology suddenly appeared out of nowhere, right? Like magic? But we're going to prove that it is absolutely not an overnight success. Actually, it's a fascinating and honestly somewhat turbulent 70-year evolution. And by understanding the structured history, we can really start to grasp exactly why AI behaves the way it does today.
So rather than just throwing a bunch of dates at you, let's start at the true intellectual beginning with Alan Turing. In his landmark 1950 paper, Turing posed a really simple yet incredibly profound question. Can machines think? But Turing realized pretty quickly that thinking is just an impossibly difficult word to define. So he did something brilliant. He shifted the focus entirely away from philosophical debates and over to the practical performance of machines. He proposed his famous imitation game, what we now call the Turing test. Basically, he argued that if a machine could act in a way that was literally indistinguishable from a human, well then, we should consider it intelligent. This wasn't just some abstract debate, this was the exact spark that ignited the entire field. Here is our stealth agenda for this explainer, tracking the epic hero's journey of AI. We'll kick off with the Turing test in 1950, look at the Dartmouth workshop, whether the AI winters of the 70s and 80s, witness the massive deep learning breakthrough in 2012, and finally arrive at the foundation models of the 2020s.
Section 1. The core question and the Dartmouth workshop. Picture the summer of 1956. Pioneering researchers like John McCarthy and Marvin Minsky gathered at Dartmouth College. And they came together based on this incredibly ambitious conjecture. The bold idea that literally every single aspect of learning or intelligence could be so precisely described that a machine could simulate it. This was the defining moment. It was when the field truly crystallized as a dedicated academic pursuit, rather than just a bunch of scattered mathematical experiments.
But you know what's really fascinating here? The origin of the term itself. The very name artificial intelligence was a deliberate branding move. John McCarthy specifically coined that phrase because he wanted to completely separate their new work from the older cybernetics crowd. He was particularly trying to escape the influence of Norbert Wiener, whose work was highly concentrated on analog feedback. McCarthy wanted a totally fresh start, one that was focused on digital computers and symbol manipulation.
Moving on to Section 2, the age of rules versus the winter. Throughout the 1960s and 70s, the totally dominant approach was symbolic AI. Early researchers honestly believed they could just teach machines the rules of human logic. It was a very top-down approach, basically built on if X, then Y statements. And hey, this worked wonderfully for closed, highly structured systems like playing chess or proving math theorems. But they learned the hard way that this rigid symbolic approach just couldn't handle the messy reality of human cognition. The real world is uncertain, it's complex, and it is highly fluid. Think about it. You don't recognize a cat by checking off a strict list of logical rules in your head, right? You just know it when you see it. Symbolic AI was just way too brittle to handle that kind of nuance. And because of those brittle, rule-based systems, progress inevitably hit a wall. These early researchers had made massive, glowing promises to government funders, like the Department of Defense, that they simply couldn't keep. So when the technology fell short, it plunged the entire field into these incredibly cold AI winters. During the 1970s, and then again in the late 1980s, funding absolutely dried up. AI became almost a dirty word in computer science circles, which is something that deeply shaped the cautious funding and development cycles we still navigate today.
Section 3. The connectionist underdog, machine learning.
So while symbolic AI was freezing over, a massive paradigm shift was quietly emerging in the background: artificial neural networks. This is machine learning, and the idea here is totally bottom-up. Instead of teaching the machine the rules, you give the machine a massive ton of data and let it find the patterns and learn the rules for itself. Now, it sounds great in theory, but for literally decades, these neural networks were mostly ignored because they lacked two crucial ingredients to actually work in the real world.
Which brings us to Section 4, the Big Bang of 2012, AlexNet. 14 million. Let that staggering number sink in for a second. That is the number of labeled images in an incredible dataset called ImageNet. Starting in 2007, a researcher named Fei-Fei Li realized that to actually make neural networks smart, you had to map the visual world. She used Amazon Mechanical Turk workers to painstakingly label millions and millions of images. And this dataset finally provided the massive scale of raw material that neural networks had always desperately needed but never actually had. So here is the absolutely crucial point. A model named AlexNet, created by researchers including Alex Krzyzewski and Jeffrey Hinton, finally succeeded because three distinct technological factors perfectly converged. First, they had big data, thanks to ImageNet. Second, they utilized deep convolutional neural network algorithms. And third, they finally had the compute power to run the whole shebang. Krzyzewski actually trained this massive 60 million parameter model in his bedroom, using two off-the-shelf consumer NVIDIA gaming graphics cards. It was a total underdog story. AlexNet entered the 2012 ImageNet competition and completely crushed the field by an unheard-of 10.8% margin.
As Fei-Fei Li pointed out, this convergence was the unequivocal turning point for the entire industry. It proved once and for all that deep learning was not just some theoretical pipe dream. It completely thawed the AI winter for good and shifted the entire computer vision industry away from manual rulemaking directly toward neural networks that learn from data.
Section 5. Foundation Models and AI Governance. Fast forward to a major architectural breakthrough in 2017 called the Transformer. This ushered us into the era of foundation models. Unlike AlexNet, which was really narrowly trained just to recognize images, foundation models are trained on literally internet-scale amounts of unlabeled data. This makes them adaptable to a massive variety of downstream tasks. This was the monumental shift from AI merely predicting or categorizing things to generative AI, systems that can generate incredibly complex language, logic, and code totally on demand.
But, because these generative systems are deployed so widely across society right now, a brand new challenge has emerged: AI governance. AI has officially moved from being a computer science lab experiment into a board-level business strategy. Organizations now have to manage what's called the alignment problem, basically ensuring these highly capable systems actually align with human intent. Because they're ultimately just predicting patterns, they can confidently hallucinate false information. And let's be real, you've likely experienced that firsthand if you've used a modern chatbot at work. So governance has become absolutely mandatory to mitigate these flaws and ensure responsible deployment in the real world.
Which brings us to the end of our journey today. We have seen exactly how AI transitioned from humans trying to write rigid top-down rules for machines to machines learning fluidly from the bottom up using massive amounts of data. But as these foundation models become increasingly capable of generating their own complex logic and reasoning, well, I'll leave you with this provocative thought. If AI spent 70 years shifting from following rigid rules to learning fluidly from our world, what happens when it begins writing the rules for itself? It's a wildly fascinating question to consider as you watch this incredible paradigm shift continue to unfold. Thanks for joining me on this explainer.